Hi everyone, it's Riley again, and today we're going to be going over the last sequences example. This is going to be example number 4, which is the sequence a sub n equals n over e to the n is decreasing. It is bounded above by 1 over e and below by 0. So as always, feel free to pause the video, work through your own solution, and I'll reveal my solution once you're done with that. All right, so for this problem, we're going to be translating that sequence to a function. So we're going to work with f of x equals x over e to the x. So we can do this because we can see that f of 1 equals a sub 1, f of 2 equals a sub 2, f of 3 equals a sub 3, and so on. So differentiating f, we get f prime of x equals 1 minus x over e to the x. So since f prime of x is less than 0 for all x greater than 1, and we can see that by plugging in x equals 2, we get negative 1 over e squared. So this term is always going to be positive for x greater than 1. This term is always going to be negative for x greater than 1. Thus, the quotient of a negative and positive number is always going to be a negative number. So f prime of x is less than 0. So this tells us that f decreases on the interval from 1 to infinity. Thus, f of 1 is greater than f of 2 is greater than f of 3, and so on. But from our previous slide, we showed that f of 1 equals a sub 1, f of 2 equals a sub 2, and f of 3 equals a sub 3. So by saying f of 1 is greater than by saying f of 1 is greater than f of 2 is greater than f of 3, we're also saying that a sub 1 is greater than a sub 2 is greater than a sub 3. Therefore, the sequence is decreasing. So first we're going to look at the upper bound of the sequence. Since it's decreasing for n greater than 1, the first term, a sub 1, is going to be the least upper bound of the sequence. So that's going to be a sub 1 equals 1 over e. And then next, since all the terms in the sequence are positive, and the sequence is continually decreasing, 0 is a lower bound for the sequence. And we can also check that all the terms in the sequence are positive by looking here. I mean, it's going to be e to the n is going to be positive for n greater than 1, or greater than or equal to 1, and n is also going to be positive for n greater than or equal to 1. So the sequence will always be positive and decreasing. So yes, that explains why 0 is the lower bound for the sequence.